This video covers review for the retest 4 over functions. So problem 1 has asked me to list the ordered pairs in relation. So when I list them, remember this is a negative quadrant. This is positive negative. This is positive positive and negative positive. So when I go to this point, I go 1, 2, 3, 4, negative 5, 1, 2, 3, 4. So negative 5, negative 4. For this point, I go over to the left 5 and do not go down any. For this point, I go left 2, up 1. This point, I do not go left or right, so that would be 0, but I go up 6. This point goes to the right 3, down 4. And this point goes to the right 7, up 2. To list the domain, because this is discrete, how do I know it's discrete, you ask? Good question. All of these points, let me erase my points. All of these points are listed out separately and seem unrelated. So when I give the domain, I give it with the little squigglies. My domain is my x values. Negative 5 is listed twice, so I don't have to write it twice. I just have to make sure they're all covered. And then the range is the y's, still discrete, so I just write the y's, negative 4, 0, 1, 6, negative 4 is already written, and 2. So domain is all of your x's, range is all of your y's. Then they ask, is this a function? The answer is no. The reason is that you have an x that repeats at negative 5. You could also say if I were to draw a vertical line on the graph, it would not pass that vertical line test. 6 asks me to state the domain and range. So domain is my x values. Here my x's go all the way to the left to 0. At 0 there is an open bubble. And then all the way to the right to 6. And then at 6, there's a closed bubble. So remember, domain is your x's, range is your y's. My y's go down to negative 3 and all the way up to 7. At 7, there is a closed bubble. So remember, you can kind of box your function if you can. Problem 7, if I box it, I can box this part, but I can't box the other part. So I could draw some arrows on there to help me remember what's happening. My domain is my x's. My x-axis is the horizontal one. So my x's are at negative 3 and are pushing to the right. So my x's are getting greater than negative 3 because to the right for x's means bigger. My y's are at 5 and are pushing down. So my y's are getting smaller than 5 because going down on the y's means to decrease or to get smaller. So main things from this page: domain is your x's, range is your y's. You can box your function, or if you try to box and it doesn't work, you have to change your inequalities. Remember that continuous functions that have the line, so this problem has the line there. Continuous functions need the inequalities for your domain and range. On the back, they are asking me to find some specific values. So there's 2 ways that we can do this. The first is to put this function into y equals in your calculator and use your table to find x of negative 3. The alternate way, if you don't remember that, and maybe that's why you're doing a retest, is to plug these in by hand. The f function means I need to use the f of x function here, and instead of instead of x, I'm going to plug in negative 3. When I do this, negative 3 times negative 3 is a positive 9. 2 plus 9 is 11, or you could also just plug that into your calculator. G of negative 2, this time I'm going to use the g of x function, so negative 2 squared plus 6. Be very careful if you're doing this by hand, that if you have an x squared or anything squared, that you put that in parentheses. Negative 2 squared is 4 plus 6 is 10. Problem 10, they want g of 3 minus f of 2. So g of 3, I'm going to use that g function, would be 3 squared plus 6. And then I need to find f of 2 and subtract all of it. Oh, sorry. Oh my gosh. My f of x function is 2 minus 3x, so 2 minus 3x. Okay, I will get this. So, this part, 3 squared is 9. 9 plus 6 is 15. This part, negative 3 times 2 is negative 6, so 2 minus 6 is a negative 4. Put this in my calculator, 15 minus negative 4, and we get positive 19. Again, your alternate way is to use y equals, plug your functions into y equals, and use the table. If you don't remember how to do that, I can't show you on here, but you can ask your teacher before you take the retest. 11, ask which of the following is a function. Being a function means your x's don't repeat. It also means if you draw a vertical line, it will pass the vertical line test. So A would not pass the vertical line test. B would not pass the vertical line test. C only passes through one time and would pass. D does not, because if I could draw straight lines, they would be hitting at all of these different points. Again, for 12, not a function means your x's would repeat. X's are the first point in your points. So when I look at A, my x's do repeat at 3 and 3. B, they are all separate, so that is a function. C, they are all separate, that is a function. D, they are all different, that is a function. 13 now wants a function, so your x's don't repeat. So if I look at these, 3, 4, 3, this is not a function. 3, 4, 5, 2 is good. 3, 3, 3, that is not a function. 3, 4, 5, that one is a function. So option 2 and option 4, which looks like answer choice B. And then problem 14 asks us to identify if these are discrete or continuous. You pay $3 for each pair of socks that you buy. Can you buy separate socks? Can you buy one sock and not buy both socks or the pair of socks? No, so it is discrete because it cannot be broken up. You pay $4 per square foot of wrapping paper. Now, wrapping paper, you can break up measurements for square feet, so that would be continuous. So wrapping paper, you could get 1 foot or 2 foot or 3 foot, etc. You can jump 20 times in 30 seconds. Can you break up those 20 jumps? Yes, you can. You could jump, if you could jump 20 times in 30 seconds, then you could say you could jump 10 times in 10 seconds. And break that up a little further. I'm sorry, 15 seconds. And then you can jump 5 times. That would be discrete because you can't break that up. You could jump 1 time or 2 times or 3 times, but you're not given a rate.